Good morning, students. Today we are discuss about lesson ninth portion, lesson number 3, electrical charges and electricity, right? So now we are discuss about measurement of electric current. Okay, so we can measure the value of current and express it numerically. Current is the rate at which charges flow fast a point on a circuit. How much of the charges flowing on the circuit? Okay, wow. That is we are measuring. Okay, that is the measuring of current. The electrical charges means Q. That is a quantity of charges passing through a cross section of the wire in the time. Quantity of current I is represented as I equal to Q by T. It's a standard units of current is ampere. The symbol of capital A. Current of 1 ampere means that there is 1 coulomb of charge passing through a cross section of a wire every 1 seconds. We have to calculate the every 1 second. Okay. Upon 1 ampere. So, the 1 ampere equivalent to 1 coulomb by 1 second. 1 ampere equivalent to 1 coulomb by 1 second. Right. So, how to you calculate? What instrument you have to use it? Ampere. Ampere is an instrument used to measure the strength of electric current in an electric circuit. How much of the charges flowing on the circuit, that is measuring used to the ammeter. Okay, that is instrument. Ammeter is connected in the series in a circuit. How do you connect the ammeter? It's a series. Series wise we are connect. Where the current is to be found, the current flows through the positive red. Positive means red terminal of ammeter. Okay, the flow of the current through the positive terminal. It's a leave of the current. It's a through the negative terminal. Okay. So now you see this. This is a ammeter, battery, and then key, then glow of bulb. Okay. So next you see. Okay. Next, electromotive force. Electromotive force means short form EMF. EMF. Now you see, you take to one pipe. Both side you are close it and fill it water fully. Now you see, you fill it. Now you see that water pipe, the water pipe inside having to the water, it's a moving or not? It is not moving. So example of you take to the one tube. Okay, a plastic tube you take, you fill it that water and both side is closed. Okay, what happened? The water is moving? It not moving. It's here. All of you that place only the rest motion only. Okay, it's not moving. What you are doing means one side you are cut it and connect to that one pump. Okay, that is air pump. Something you are connect to the pump. After what you are doing, the pump you are pushing means the water also pushing that pump. Okay, the pump pushing means as some of the air pushing to the water. That times what happen? The water is here moving in the circular. Okay, moving in the water tube or circular, anything. Okay, it's a moving in the device only. Which one? Water. How to? You are pushing to some of the energy you are giving. Some of the energy you are giving. That energy what happen? Pushing to the water. So the water is here moving. Okay. This is we are telling to electromotive force. That is a EMF. It's a moving now. The same like only one battery you are connected to the electric wire. Okay. So what happens? The battery is here on means what happened? Already that electric wire having to the electrons. Already the electric wire having to the electrons. It is a rest motion. You are connect to the battery. You are applied to some of the electric force. this that wire having the copper wire having to some of the electrons. The battery what happen? Pushing. Yeah, it's a battery giving to some of the energy giving means the electron also moving to that circular area. Okay, this is we are telling to that EMF. Okay, so you see that EMF, the electromotive force represent as the E. The EMF on the electric energy source is the work done by the source driving unit charges Q around the complete circuit. So E equal to work done. Okay, work by Q. Q is a charges. W is a work done. The SI units of EM is a joules per coulomb or volt. Okay, we are calculating the coulomb, joule per coulomb or volt. Okay, this unit we are using. The EMF of the electric energy source is 1 volt if your 1 joule of the work is done by the source to drive 1 coulomb of charges complete around the circuit. Complete around to the circuit. Okay. Next you see that potential difference. What is that potential difference means? Potential difference means one circuit. Okay, the potential difference, the circuit, whatever it is, we are flow to the current charges. It's a moving to the charges. Okay, the positive terminals having the energy, positive terminal having to that energy, that is a flow to that negative charges, say moving to the circuit, the electric circuit moving to the electrons. So how much of the electrons moving, how much of the charges moving, that is we are calculating the potential difference. We have to use into the voltmeter. Okay, how much of quantity, how much of the quantity we have to use in the charges. Okay, that is current. How much of the current we have to use it. Okay, so that one you have to find out that using to the voltmeter. Okay, are you understood? So first you see that you are taking to the one bulb and connected to the switch, key and battery. Okay, the battery it's on means what happens? It's immediately flowing to the current. To reach the bulb, automatically the bulb is glowing. Okay, so sum of that, the quantity, of that charges your flow to the bulb. That charges, that quantity of the charges we are find out through the voltmeter. That is we are telling to the potential difference. Okay, so now the potential difference we have to find out the voltmeter. So that voltmeter we are connected to the series. Okay, series wise we are connected. Okay, so that how do we are find out? That means V, voltmeter, V equal to W by Q, where W is the work done, amount of the electrical charges converted into the other forms of the energy measuring in the joule, and Q is amount of the charges measured in the coulomb. The SI unit for both EMF, the potential difference is the same. Okay, so EMF volt la calculate pannalam, potential difference we are calculate to the volt. Okay, so next you see that resistance. Okay, resistance. The resistance is the measure of the opposition offered by the component to the flow of electric current through it. Okay, it's a through it. Difference electrical. The metals like the copper, aluminium having have a very much of negligible resistance. That is why they are called good conductor. On the other hand, material like the nichrome in the oxides, etc. offer high resistance to the electric current. We also have the category of material called the insulator. So it is not conductor to the current, we are called the insulator. Example of the glass, polymer, rubber and paper. All these materials are needed. All these materials are needed in the electrical circuit to have the usefulness and safety in the electric circuit. So the SI units of a resistance are ohms with a simple ohm. 1 ohm is the resistance of the component when the potential difference of the 1 volt applied cross the component derives a current of 1 ampere through it. We can also control the amount of the flow of the current. So resistance is control of the flow of the current are called the resistor. The resistor can be fixed in the variable. So three types of the resistor are, so you see, one is a fixed resistor, another one is a variable resistor, another one is a rheostat. The fixed resistor have the fixed value of resistance, while the variable resistor like the rheostat can be used to obtain the derived value of resistor. Okay. Thank you children. Next class we see.